I'm going to show you how to make a simple vehicle, one that drives and steers, and a microcontroller that you'll be able to use on each of your vehicles. I like starting with the bottom drive line. It's a good start to making the chassis of the vehicle. It lets me know what shape I'm going to start with and what shape I'm going to end with. So it's going to be a straight pipe with two T-pieces on the end. And then I'm going to turn on mirroring on the X-axis temporarily. I'm going to place four 5x5 wheels here. I chose 5x5 because they're easier to see. There's no importance. It can be 3x3s, it can be 7x7s. They're just different sizes, does not matter. And then I'm going to delete this piece of the axle and place a block so I can have a building place to start off with here, and then replace that axle there. Next, we're going to type in modular into the menu here, and we're going to have all of our modular engine pieces that we're going to need open up and ready to be chosen. I'm going to start with the crankshaft. The crankshaft is simple enough. It goes there, and I'm going to send it back 2 blocks and delete this first one. Next, we're going to use the modular engine drive belt, and it has this circle on the back of it that goes to the circle on the crankshaft. I want to remind you that all the crankshaft blocks go connecting via the circle, so this will not connect, this will connect, this will not connect, this will connect. These two crankshaft pieces are connected, and they are connected to this drive belt as well. The drive belt is where we attach the fluid pumps, alternators, and starters. I'm going to turn off X mirroring now. I'm going to attach the fluid pump to the top. I have it in this orientation. It's not flipped, it's not rotated at all. It does not matter which direction it faces. Same with the starter and alternator. They can be on either side, and it does not matter which direction they face, as long as this rectangle is touching the rectangle on the drive belt. This one here. And then I'm going to put an alternator on the other side. I'm going to continue on with our modular engine parts. I'm going to place 2 cylinders on each side. So the cylinders need to attach via this square face onto the square face of the crankshaft. They cannot attach to the circle face, and they cannot attach to each other via the circle faces, or the 4 circles on each cylinder. They need to be attached to the crankshaft by the square face. They can be attached anywhere there is a square face. But if we're going to have 2 banks like this, we're going to need manifolds to connect each bank. And the modular engine manifolds are corner, straight, and T. These are different from the fuel and air manifolds because these only transport resources from one bank to the other bank. So I'm going to need a corner, a straight, and then another corner to connect these 2 banks. And I'm putting it on the back so we have room to use our fluid pump here. Next, I'm going to put the fuel manifold on the bottom left side, facing backwards. Notice that the fuel manifold has this face that has the 4 circles on it. This 4 circles face needs to go to the 4 circles face on the cylinder. It can also attach to the 4 circles face on a fuel manifold if you need to move it to another location. But since we're keeping this simple, I won't do that. I'm then going to use some pipes and just get that ready for our fuel tank. I'm going to move it out of the way so we can put a medium fuel tank here. Next, I'm going to get the exhaust oriented. I'm going to use a modular engine exhaust manifold corner and place it right here. Next, we're going to need a engine coolant manifold, and I'm going to put it here. And then last, we're going to need an air manifold. The air manifold is going to go here, pointing to the right. So all of these resources that we just attached to the engine are going to be shared between the banks because of this connecting manifold. A lot of people will forget this connecting manifold, including myself. And this is vital to the running of the engine. If you have an engine that only runs on 1 bank of cylinders, you will not need it. But if there are 2 banks or more, you will need it. You can also replace this straight manifold with a cylinder. I just think it looks silly, and that's the only reason I don't do it. Next, we're going to use pipes. I like orienting my pipes in my hotbar like this with the numbers correlating to them so I can use them easily. But our first pipe is going to go here, facing forwards. Next is going to be the same orientation, just behind. Again, it does not matter which direction the fluid in or fluid out are facing, because this is a bidirectional system. It does not matter which direction it goes. The last piping is going to go like that. I'm going to paint it blue so it stands out a little bit more. This is our coolant system. Next, we're going to need a radiator. So we're done with all the modular stuff for now. We're going to type in radiator and find that. Then the radiator has these two inputs and 2 inputs or 2 outputs. They can be either way. It does not matter the orientation of it, as long as these 2 circles are connecting to the 2 circles on the pipes. So like that. So these 2 connect together here. And then this connects to the pipe here. This pipe connects it to the coolant manifold here, and then to the pump right here. And that is a simple cooling system. It all fits well into the chassis as well, because I made the engine 2 blocks tall where the wheels are. Next, we're going to do the exhaust system. So I believe if you type exhaust, you don't get the catalytic converters, but that's okay. We don't need a catalytic converter. I'm going to put an exhaust piece here. You can use a fluid port as well. It just doesn't look as good, but it works. Same with the air intake. I like using an air filter. It does the exact same thing as a fluid port. It will work either way if you use a port or an air filter. The fuel is slightly different. You'll need a tank, and then you'll need a gas relief system on the tank, and that's very simple. All you need is a gas relief valve and a port of any type, including air filters, fluid ports, even fluid slot ports, any port that allows air to flow in or out. As long as this gas relief valve is here, we won't leak any fuel and we'll only relieve extra pressure in the fuel tank. And that is because in this game they made fluids and specifically liquids ever so slightly compressible so that they can manage to have a pressure in them. And when you spawn in a fuel tank, it will have excess pressure and it will need to vent that pressure. It will also lose, it'll also lose pressure when you start to run low on fuel, and that'll end up sucking fuel out of the engine as it becomes lower than 1 atmosphere pressure. And so this vent here keeps it above 1 atmosphere, allowing us to keep using any fuel that's remaining. Next, we're going to move on to making the transmission. The transmission is special in the way that I like doing it. It's very simple. Start with the clutch. The clutch has this circle on the back of it that correlates to the circle on the crankshaft. These 2 connect together. The clutch does not connect to anything else on that circle spot. It only connects to pipes on this side. So we're going to get a gearbox, and I like facing it in this orientation. That is because the bigger side of the arrow is the bigger gear, the smaller side of the arrow is the smaller gear. That's the best way to remember it, I believe. So we go from a high ratio to a low ratio. We're going to start with 3:1 and 9:5. Same on the next one. 3:1 and 9:5. And on the last 2, since they're the other direction, we're going to leave the top one as 1:1 and the next one as 3:2. So these 2 are both the same. These 2 are both the same. They're just facing opposite directions. The last gearbox we use is for our reverse gear, and I point it the other direction to indicate that it's different. We're going to put that in 1:1 and 1 to -1. That way we can have reverse available. And then we're going to connect this to our axle that connects to both wheels with a T-pipe in a corner. And then lastly, we're going to put a battery on here because I always forget the battery and wonder why it won't start. I'm going to stuff the battery down here. You can put it really anywhere. I like putting it lower because it lowers the center of mass here. And then before we forget, I'm going to attach all the electronics. To attach all the electronics, you can hold left control and then click on this one, just click, not hold. And you can click on all the other spots and connect them up individually all at once, instead of having to draw and connect individually. It's very useful when you're using a lot of electronic components. It's a good little tip. And then I believe we're ready to start our microcontroller. To start our microcontroller, oop, that's not it yet. We're going to start with naming it. And then I'm going to need a 4x3 space. We're going to start with our seat intake, or input. So our seat, we're going to use the composite from the seat, and this might sound scary at first. Composites were very scary to me at the beginning as well, but I promise it gets very simple. Composites will carry 32 channels of number and 32 channels of on-off inputs and outputs at the same time. And the seat outputs several on-offs and several number outputs. The seat's first axis on its number output is the steering axis. The second one, so channel 2, is our throttle or braking. And then channel 3 and 4 are left and right arrows and up and down arrows, which we're not going to use on this situation. We're only going to need our first two axes and then our on-off from one, and I'll show you how to do that later. But trust me, all you need to do is connect this to the seat and it will do the rest. This keeps everything a lot simpler. Next, we're going to need a number output for our air throttle, another number output for our fuel throttle, a number input for our engine RPS, a number output for our clutch, a number output for our steering, a number output for our steering inverted, and I'm going to place it under the composite, and we can do that because they updated it to where we can have composites layer over the Boolean and numbers. So I'm going to change this to another number output and name it steering inverted. And then I'm going to place it under the composite here. You'll see it because there's a green dot under the composites layer. Next, we're going to need a on-off output, and I'm going to label this 1. This is for our first gear ratio change. The next one is going to be the same thing, but labeled 2 for our second gear ratio change. We're going to use 3, and lastly 4. They're all outputs, 1, 2, 3, and 4. And then we're going to use something that I use. This is where it becomes a little bit more special and much more usable, is a driveline RPS sensor, and that is an input. This is going to be used in our steering system so that we can decrease the amount the wheels steer at higher speeds so they don't understeer or oversteer. It allows the vehicle to maintain much better control. And then lastly, we're going to use a number output, and as our brakes. Also, if I didn't say yet, you can click on each of these nodes to go to where it is in the logic menu. That way you can find them real easy. And that is all of the logic inputs and outputs that we'll need for this microcontroller. It is 13 total. Now, that's going to go up there. We're going to put this one over here and stack up the 1, 2, 3, and 4 because they're all going to be used in the same little system. I like to put the steering in the bottom left because it's a fairly small system and it's going to be close to where I'm going to put the seat. The clutch is good to go with the engine RPS and the clutch and the driveline RPS. Actually, the driveline RPS needs to go with steering. Fuel throttle goes up here. I put my air and fuel throttle system up in the top. And this input is our seat. I forgot to name it. It's at the top because it's the first one we did. I'm going to name it seat. That's our driver's seat input. For our driver's seat input, the driver's seat composite system outputs on channel 1 and numbers. You can hold shift to place multiple at the same time, by the way. On our first axis, that is our steering, and our second axis, that is our throttle or brake. So I'm going to start with our steering system down here. We're going to need a function, and it's going to be a XYZ function. I'm going to move these out of the way because we're also going to need an fx function. I'm going to connect that here and here, connect these two together just like this, and then this value goes to x, this value goes to y, and then I'm going to put a specific function in this one, and that function is going to be x divided by, open parenthesis, absolute value of y plus 1, close parenthesis. And I'm going to take a picture of that graph and put it in, stitch it in here so you can see it. Effectively, that allows our steering to decrease as we increase in speed so we don't oversteer or understeer, allowing us to maintain control of the vehicle much better. It also looks a lot more refined. This f of x function is just going to be simply negative x. It can be x times -1, x divided by -1, whatever you want it to be, as long as it just outputs the negative of x. I think a negative x is the simplest way you can do it. And that is our steering system done. Next is our brakes. Our brakes are going to get a little more confusing, even though it is less objects, and that is because I'm going to use a clamp function. The clamp function, I'm going to show a graph of it as well. Simply, that is the graph I'm going to show. It takes the value of x and it limits it to 0 or 1. So if the value of x is 0.5, it will output 0.5. If the value of x is 1, it will output 1. If the value of x is 2, that's greater than 1, so it'll only output 1. Same thing for 0, but less than instead of greater than. In this case, we're going to change it to negative x because when we press on the brakes, our seat is going to output -1 because we're pressing S, which is backwards. And since we're outputting -1, we're going to want to multiply that by 1, and that is going to allow, or by -1, that is going to allow us to change this value to a +1, which is what we want to output to our brakes to make them brake. Lastly, I'm going to divide this number by 10, and that is our system of anti-lock braking, because if you output the full value of 1 to the brakes, it will lock up the wheels and you will not be able to steer while you're braking. That is how you lose control and fall off a cliff. So that's our brakes done. Next, we're going to do a idle and throttle and clutch. I'm going to move the clutch out of the way a little bit. We're going to start with clutch because that is the simplest one to start with. It is one function. Just connect that from engine RPS to the clutch. Our function for the clutch is going to be x minus 3.5 divided by 2. And I'll show that function on screen. I'll stitch it in. Effectively, what it does is it takes our x input, which is our engine RPS, and makes it to where when our engine reaches an RPS of 3.5, it begins to apply the clutch. And by 5.5, it has fully applied the clutch. That allows us to disengage the clutch when it's on idle or when we're not using the engine, but then engage the clutch whenever we need it. And that is because when we use the engine, we're going to throttle up and it's going to raise an RPM or RPS, and it's going to increase, and that will gradually increase the clutch as we need it. That way we don't have to manually apply the clutch and it doesn't stall itself. Next, for engine RPS, we're going to do the idle system and our throttle system. Now this is where it gets a little bit more complicated because we're going to use another 2 clamp values. I have engine RPS connected to X and our throttle input connected to Y. So our engine RPS is going to be a value from 0 to like 12. I'm going to limit the engine to 12 RPS. And then our throttle input currently is a value from -1 to 1, where -1 is fully braking and 1 is full throttle. So we're going to need to clamp our throttle input from 0 to 1. That way we don't get our braking input as throttle. And we're going to need to clamp the output of this function so that we don't output more than 1, because that will mess with our fuel system. So the function is going to be clamp of 1 over x minus 3. I think I'm going to put these functions in the description of the video so that they can be copy and pasted, because they do take a little bit of attention to just copy down. We're going to place, so that is our idle system. What it's going to do is as our engine approaches 3 RPS, it's going to raise the value output because x minus 3 is going to approach 0. And as that approaches 0, this function outputs, it approaches infinity, which means it approaches the maximum our throttle can output. This is a system you learn in Calculus 1 called limits. I'm sure plenty of you are familiar with that if you know what this game is. But if not, that's what this is called. That will output for our throttle output. Next, we're going to add the clamp of our throttle input, which is going to be Y, 0 to 1. And then we're going to output 0 to 1 again, because that clamps our throttle plus our idle input between 0 and 1, so we don't output too much. Lastly, I'm going to make our RPM limit and our engine turn-off system. So we're actually going to start with a read on or off from the seat, and we're going to keep it on channel 1. This read on or off is going to read our, as we press the number 1 button in the seat, it's going to toggle on or off the engine. And so what's going to happen is we're going to place this number switch box, and what is going to happen is it's going to send our throttle through the off signal, and we're going to place an OR and a NOT. So as the engine is toggled on, it's going to turn this value from on to off, which is where we get our throttle, and that's going to go to our air throttle. And the reason I do this instead of just toggling it to the on and putting this one in the on value is because we're also going to put our RPS limiting system. So if our engine RPS is greater than 12, which is what I'm going to set the limit to, and then connect this to the OR, that means that it will toggle this to on, which outputs 0 for our throttle, which allows the engine to rev back down below 12. This goes through here, so if the engine is on, that means this outputs off, which allows this to output off, which allows our throttle to go through. Lastly, we're going to take a single function piece and x times 0.47. This number can be anywhere between 0.47 and 0.5. 0.5 is much more fuel consumption, but it also outputs a little bit more power. 0.47 is less fuel consumption and a little bit less power. I keep it at 0.47 because the power difference is very minor, but the fuel consumption is considerable. And that is going to connect our primary throttle output to our fuel throttle, and that is going to maintain our stoichiometry and mixture just enough to where we don't have to do a whole complex management system. And that is how you manage the throttle of the modular engine. Then finally, we're going to do our transmission, which is going to be these here. I'm going to do this and move them out of the way because our program for it is going to be fairly long. So I have calculated, I've done the math, and the engines, the modular engines, run the best at 6 RPS. They are the most fuel efficient for the power they output. And so I want my engine to drive around 6 to 8 RPS whenever I'm driving at full throttle. That way I get the best power output for my fuel consumption and it doesn't overheat the engine. So what we're going to start with is 2 greater than blocks. Hold shift to place 2 again. We're going to get 2 constant numbers, place them here and here, and then connect our engine RPS to the top value on both greater. Actually, no, that's not supposed to be a greater than, that's supposed to be a less than. Sorry. Engine RPS to the less than and greater thans. So these two are both our engine RPS. I'm going to connect these constant numbers here. And then our greater than number, I want it to shift when it gets above 8 RPS. And I want it to downshift when it gets below 4 RPS. That way, we keep our engine between 8 and 4 RPS, which is as close to 6 as we can get. And the reason that 4 is 4 instead of being 6 or something less than is because when we shift gears, our engine RPS is going to change from 8 to anywhere between 4 and 6. And if we place the number 4, our constant number 4, any higher than that, it will immediately downshift, thinking it needs to, when it doesn't actually need to. So this value should be twice what this value is. approximately. Next, I'm going to use blinkers, and the reason I do this is because when we upshift, if we continue at an RPS above 8, then it won't know to keep shifting upwards. So the blinker tells it, shift upwards once, and if you need to again, keep doing it. Then we're going to use a toggle to push, which is here. These tell the system to not continue shifting up. It tells it to just blink and shift up one gear instead of shift up all of them. And that is because we're going to use a up-down counter. Clamp this between 0 and 3. So turn on the clamp, place min at 0, maximum at 3, and then connect the upper one to up and the lower one to down. Lastly, we're going to use 4 threshold blocks. Hold shift to place multiple. I'm going to move these closer now. Connect the output of this one to each of these numbers. And then this is where it's going to get a little bit interesting. We're going to place the high threshold at 4 and the lower one at -1. No, wait, 0.5. There we go. This one at 1.5 and at 4. This one at 2.5 and 4. This one at 3.5 and 4. This needs to be 4. My bad. And then connect each of these. Just to let you copy all this down. Make sure these values are all the same and all of these are the same. I'm going to give it a pause for a moment. And that is our transmission and ECU done. So we're going to go back to here, draw a little drawing so we know which one it is, make sure it's named, and then save it. And then we're going to go back to our car, find our microcontroller. I typed in tutorial car to find it. I'm going to place it right over here so it's parallel with the floor of our car. And then I'm going to connect everything up. So I'm going to start with the brakes. The brakes go into the top number input in the wheels. Remember, hold control and you can connect them multiple at once instead of having to drag and drop each one. I'm going to go to number 3, which is this one from the front because it's number 3 from the front. Engine RPS. It's going to connect that to either point on a crankshaft. Both of them will output the same number. It does not matter which one you choose. Fuel throttle is going to go to our fuel throttle manifold, which is down here on the bottom left. Our clutch is going to connect to our clutch pressure on the modular engine. Our air throttle is going to connect to our air manifold. Number 2 is going to connect to our 2 gearbox. Driveline RPS. I forgot to attach that sensor, so we're going to do that now. I'm going to attach it right here. So I'm going to take a T-piece, face it left, and a corner piece, face that forwards, get a torque sensor, torque meter, place that connected there, and then go back and connect the RPS of the torque meter to driveline RPS. We're going to go to steering inverted. The inverted one, as opposed to the regular one, is going to go to our left wheel, and the regular one is going to go to our right wheel. If you get these backwards, the steering will be the opposite, and you'll just have to flip them. Number 1 is going to go to our first transmission gear, and 4 to our last one. And you might think we don't have reverse connected. That's because we don't have the seat yet. We need to connect the seat and build it first. We need to connect the seat to the microcontroller now. The seat is going to connect with our composite, which is going to be at the bottom front of the seat here. Remember, make sure it says seat data. Connect that to our seat input over microcontroller. So now we have control over our microcontroller. Next, I'm going to connect our number 1, which is currently a toggle, to our radiator. That way our radiator turns on whenever we turn on the engine. And then I'm going to change number 2 to a push button and name it starter and name our number 1 accessories. That way we can turn on the accessories and then turn on the starter separately. Also, while I'm here, I'm going to change our AD and WS sensitivity to 100% so we get instant response. It's a little annoying whenever there's a really slow response to the controls. You can change it to whatever value you want it to be, but I prefer 100 because it's the most responsive. It also does not overshoot because of the way we've set up the system for steering. Next, I'm going to connect 2 to the starter, which is over here, and then 6 to our reverse. I'm going to name hotkey 6 reverse and leave it as a toggle. And it should be everything. Now we're going to test it. There we go. Let's see if it works. So I pressed number 1 and then hold number 2, and it starts right up. We have a vehicle that drives. Notice the steering doesn't go crazy whenever I steer at higher speeds, and if I slow down using the brake system because we didn't make it where it locks, the steering increases because we'll be able to turn tighter whenever we're slower. If you want it to be faster, you can change the RPS limit and the upshift and downshift points to being higher numbers. Remember that the downshift point needs to be half of the upshift point, and the RPS limit needs to be higher than the upshift point. We have reverse as well. And if you do stall it by going in reverse at too high of a speed, you can hold 2 to start the engine again, and it'll go into reverse. That's it. That's a simple vehicle.